Homework 5.1, Systems of Equations, Video 5. Homework due Friday, May 29th, 11:59 p.m. This and the previous video are associated with homework questions 5 through 8. In the previous video, we developed a technique for solving 2x2 linear systems by addition. And just to summarize the general plan of attack, we do some multiplying to set up some opposites. We add the equations, the opposite terms cancel, leaving us with one variable. We solve for that, and then we go back and pick up the other. On the board, I've got a randomly generated, well, it's not so random, system of equations, but unlike the previous ones, I built this not knowing its solution. And if you're wondering, how do you build a system knowing its solution, it's actually not that hard. You write a couple of random things like that. In your mind, you say x equals y equals, plug them in, and then figure out the values. So you built the equation around the solutions. But this one, I picked the numbers at random, and I did change one of them because I want this problem to go so bad. Not bad, but annoying. You'll see what I mean in a minute, and it'll also explain why that asterisk is down there on the fourth step. Alright, so if necessary, multiply one or both equations by well-chosen numbers to set up a pair of opposite terms. In the previous video, we had a 2 and a negative 8, and it was kind of obvious that multiplying the 2 by a 4 set up opposite terms. In this case, it's not so obvious. Look at our x's. One of them is 8, one of them is 7. How do we make those opposites? Same thing with the y's. One is 3 and one is 11. How do we make those opposites? Plus, everything's positive. So how do you pick well-chosen numbers to set up a pair of opposite terms? The answer is, first, pick a letter to eliminate. A letter that you want to create opposite terms for. For example, let's say you want to make the x's opposites. There is a way to make any pair of terms opposites. The trick is to turn both numbers into the same value, except one being negative. Now, how can I turn 8 and 7 into the same number? By finding a number that is divisible by both 8 and 7. What's 8 times 7? 56. I can turn both of these into 56. How? By multiplying each equation by the other equation's coefficient. In other words, the way to always set up opposites, and this is how you can find well-chosen numbers, pick a pair you want to get rid of, take their coefficients, and reverse them. And those are your multipliers. I'm going to multiply the top equation by 7 and the bottom equation by 8. By picking a letter and switching the coefficients as multipliers, you're setting up the same multiplication problem. 7 times 8, 8 times 7. So they're guaranteed to match in value. The only problem is they're not guaranteed to be opposite in signs. So before you go multiplying, ask yourself, will these be opposite? If not, then you need to make one of them negative. Because right now both products are 56 and I need one of them to be negative 56. Now, which one do you make negative? Honestly, it does not matter. I'll just make the top one negative because I have to make one of them negative. So that's how you can multiply by well-chosen numbers. Pick a variable, grab the coefficients that are currently there, reverse them, and if necessary, change one of their signs. Actually, if you reverse them as it is with whatever their signs are, you will always need to change one of them. So I guess another way of saying it is reverse them and change one of their signs. All right, let's see what happens. I'm going to erase everything except the last step over here, just because I don't want to run into these steps as I did in the previous video. But I want to leave the last one to explain why I put the asterisk here. You'll see at the end. All right, if we multiply the top equation by negative 7, we get negative 56x minus 21y equals negative 35. And if we multiply the bottom equation by 8, we get 56x plus 88y equals 104, I believe. Let me double check that. 80 and 24 is 104. Yes. All right, we've created our opposites by design. So let's add the equations. The x's cancel. When I combine the y's, 88 minus 21 is 67. That's not a good number to divide by. 104 minus 35 is something. 69, I believe. I promise it was a randomly generated problem. Let me add these just to make sure. Yeah, so we have 67y equals 69. Dividing by 67 usually doesn't come out good. This is one of those cases. We get y equals 69 67ths. Okay, well, at least the fraction didn't show up until the end. Oh, wait, this isn't the end. This is only half the answer. And it's a fraction. Well, our fourth step says substitute the known value into any equation and solve for the unknown value. So does this mean we're going to have to substitute that fraction into the equation and proceed to solve? Well, no, we can. Don't get me wrong, it'll work. But the reason I put the asterisk there, what is it we're really trying to do? We're trying to figure out what x equals, and more generically, what the other letter equals. In this case, I can find it by substituting this and then solving, but there's an alternate way to find it. And here's what the asterisk is. Or, and again, that will always work, and honestly, so will this. So you have some options on how to get the other letter. Well, think about it. I got the y by doing this. Can't I just start over and get the x the same way? You want me to do all that again? Well, your options are do all this again, or take this fraction, stick it in there, and get busy. Okay, I'll do it all over again. So the other option to getting the other value is to start over, but set up the other variable to create opposite terms. It's not nearly as hard as it seems, because we have a way to find well-chosen numbers. So let's not substitute y equals 69 67ths in the equation. Let's start over. So let me rewrite the system. 8x plus 3y equals 5, and 7x plus 11y equals 13. But this time, I'm going to consciously get rid of the other variable by setting up opposites on the y's. You wouldn't think leaving this marker uncapped for 5 minutes would dry it out so much. Let me see if I got another red marker. No, all the other red markers have cracked out, so let's just use a blue marker. Okay, so blue from this point forward. All right, so we're going to get rid of the y's, which means we need to set up opposites here, and the technique that will always work is to grab the coefficients, reverse them, and those are your multipliers. So I'll multiply the top equation by 11 and the bottom equation by 3. But both will give me positive 33. I need to make one of them negative. Let's make the bottom one negative. There's really no rhyme or reason. Just pick one and change its sign. So let's see what happens. And I'm going to move the y down here because remember, we're creating an ordered pair, 69 67ths. And let's do it again. But this time, the y's will cancel, and then we can solve for x. So, if I multiply the top equation by 11, I'll get 88x plus 33y equals 55. And if I multiply the bottom equation by negative 3, I'll get negative 21x minus 33y, there are my opposites, equals negative 39. And if I combine these, the y's cancel. 88x minus 21x is 67x. Wait, we got 67 the last time. The y's cancel. 55 minus 39, I believe, is 16. Let me add just to make sure. Yes. And if we divide by 67, we get x equals 16 over 67. It's not really a coincidence that the denominators matched. If you retrace the steps on all of them, you'll see why that happened. But my point is, when you're solving a system by addition, actually I got several points. Number one, you can get rid of any letter at any time by simply taking that variable's coefficients, reversing them as multipliers, and possibly changing the sign of one of them. And my other point was, when you've got half the answer, one way to get the other half is to substitute, but the other way is to just start the problem over again. Now you ask yourself, what would you rather have done? Substituted 69/67 into an equation and solved for x? Or would you rather have just ran through the problem again? Frankly, either one is okay. You just choose the one you like. Now, before we move to 3x3 systems, and we are going there, I need to warn you about some things that can go wrong with 2x2 systems.